Hi, my name is Sarah Hoddes, and this is the experiment of the magnetic fluid for Chemistry 2. So first I got my materials. I got vegetable oil, some earth magnets, and ink toner, a glass to do the experiment in, and then those paper towels behind I put on the countertop so that I did not make a mess. I got the vegetable oil from Walmart, and the ink toner and the magnets I did have to get it online through Amazon because they did not have them in stock at Walmart. So first I added a little bit of the toner into the cup, and I made sure it was clear so that way I would be able to see the spikes whenever I put the magnets on it. And then I added a little bit of vegetable oil and I mixed it until it was really, really runny, like the video said too. So I didn't use the full 50 milliliters because I thought that was a lot and I didn't have something to measure that. So I just kind of played it by ear, but I made sure it was runny like the video said. So then I used the magnet. At first I used one earth magnet to see if the spikes would appear, but that didn't work, so I just used all of the magnets, which there's, I want to say 6 altogether, and it did not work. I tried putting it under, on the side. I added more vegetable oil to make sure it was runny, and it still did not work. So, what I think went wrong, I thought originally maybe I had ordered the wrong stuff, so I went back and, as you can see, I attached the Amazon screenshots, but the screenshot says rare earth magnet, and it's strong. And then the ink toner, it doesn't say LaserJet, which is what the video said, so maybe that could have been it, that it wasn't LaserJet, but it was ink toner and it was in a powder form. So I'm not sure exactly what was wrong. I thought I had all the materials correct, but what's happening? While most rare earth magnets are made from the rock-hard materials we're familiar with, not all appear in that classic solid form. Ferrofluid is a stable colloidal suspense of suprapragmatic iron oxide nanoparticles. So simply, it's a liquid that contains tiny magnetic particles, and its magnetic properties come from the magnetized iron oxide it contains. These particles are also known as nanoparticles because of their small size. The particles are actually so small that they never fully settle to the bottom of the container. So I made sure to mix it pretty well. Other than being really cool to look at, the ferrofluids are quite special in the world of magnetics because of their size. The particles turn ferromagnetic into a supermagnetic material, meaning they don't stay magnetized when removed from a magnetic field. So, ferrofluids have been around since the 1960s when they were uses were many, such as audio speaker coolants and high-end engineering seals. Dynamic rotary shaft seals are an example of high-end sealing technologies that are typically implemented by mechanical engineers in an industrial plant setting. More recently, this technology is the topic of research involving nanoparticle suspensions and engineering such materials to have greater magnetic properties under moderate magnetic fields. Materials engineers have developed new nanomaterials for medical applications targeted at localized drug delivery systems by an induced magnetic field. These injuries use basic chemistry and physics fundamentals, along with newly acquired nanoscience, to introduce particles small enough to transport through capillary systems and organs and have sufficient magnetization. Additionally, materials and biomechanical engineers design the biocompatible and biodegradable organic coatings to reduce toxicity levels and biomechanical reactions that may occur with such magnetic nanomaterials in humans or animals. Most importantly, the fluid must behave like a fluid until a magnetic field is applied. So it actually is used a lot around today and is very useful in today's society and in the medical field. A ferrofluid is a special liquid with tiny magnetic particles floating around on the inside, and since these particles are attracted to each other, They must be coated with a special substance that prevents them from sticking together, so that the ferrofluid remains fluid. What makes ferrofluid so special is that the presence of the outside magnetic field. Each of the tiny particles becomes magnetized, and the ferrofluid condenses into a solid. I wish that, that's the end of my slideshow, but I do wish that the magnet would have magnetized, because I think it would have been so cool to see all the nanoparticles come up into spikes. But other than that, it was still a fun experiment to learn about. That is it. Thank you.